All right. I thought I was going to try a new thing where I've been writing blog posts. I thought it might be nice to like have me walk through them sometimes. So the title of this post is "The C-Bounded Model Checker Criminally Underused." It's about the C-Bounded Model Checker. I'm interested in software verification. I'm interested in automated theorem provers and things, and I am fascinated by kind of low-level material, C and assembly and binary analysis and things. And sometimes when I'm writing some C, like, I don't know, like it's confusing. Is what I'm doing okay? Is what I'm doing like getting an undefined behavior? Sometimes I'm going into C because I want to do something kind of weird that's like on the edge of like what makes sense. Um, I want tools like tell me, am I doing something dumb? Like it's hard to know, and so I can like toss my code into ChatGPT and ask it to critique it. But then there's also tools that can do various checks. You want to turn on all the warnings. You can find lists of like all the warnings you want to turn on the compiler. There's inbuilt static analyzers. I haven't played too much with those, but I think they're very useful. Sanitizers that are checking for memory leaks or out of bounds buffer errors and things. And so those compile extra code into your program that slow it down a little bit, but very useful. And then there are also there's Facebook Infer, which I haven't had great luck with, but is a big deal because it's got a big company behind it and stuff. And then you can also go like hardcore mode where you're using from a C or using cock VST, something that's a really interactive experience where you're really like writing a lot of stuff. And there might be a lot of discharging via automated solvers, but still it's like another tier of expertise kind of to like use that and work even if you have the expertise. But an undersung thing you can do is just use some automated verifiers. You just like throw your C program into them, and they'll say something. They can just find bugs, and it's pretty easy to use and really impressive actually. And in terms of its flexibility too, of like it finds code paths that get to assert statements and things, and finds ways of triggering them. And it also has a claim to completeness that it's like if it says I've traversed every path in the program, like there's some reason to believe that that's like true. So what I have here is a Google Colab notebook. You can follow along, and this is downloading CBMC. There's Windows and Linux binaries like available, and I'm just downloading one and installing it, and now it's ready to go on this Colab notebook. Okay, so I want to start. Well, let's just do like the simplest possible stuff, right? So like this is a very tiny program. I'm putting it in the file temp example1.c, and it's asserting 1 is equal to 0, which is of course not true. If I compile it with GCC and then run it, of course that execution fails, and it tells you like what line that happened at. It was at line 3, and it says the assertion failed. But then also I can run it through CBMC, and it runs. It says a bunch of stuff. It's giving us data about how long things took. But then it like found a failure. Okay, not that impressive, but like we're walking before we run. And so here's the next example. So this is a little more interesting. We have an uninitialized variable x, and we're claiming that x is not equal to 1, 2, 3, 4, 5. And if I run GCC, it compiles it fine and it executes it, and there's no error. I don't know. We could dig into what x ended up being or if it even exists at all. But it didn't trigger an assertion. Whereas CBMC, if you leave variables uninitialized, it's free to like pick whatever value it wants. Is like how it works. And you can also add this trace option. There's lots and lots of interesting options in CBMC. If you type CBMC -help, you get a pile of options. It's kind of overwhelming actually until you're like into it. So this is the trace, and it said it failed, and then it gives you a trace of like, oh, it picked this value, x equals 1, 2, 3, 4, 5, and then it triggered the assertion. And then, okay, can we fix that error? Well, we can wrap this in, this is very silly, but wrap it in something that checks if x is less than or equal to 42, obviously, if x is less than 42, it can't be 1, 2, 3, 4, 5. So now it can pass this check because it'll never reach this assertion. It says success. Okay, so here's something a little more meaty, something not super realistic, but like, we're talking about like what things should be doing a little bit more. So I wrote an absolute value function that if x is less than or equal to 0, it returns the negative of x. If it's greater than 0, it returns x. Okay, great. If you have this is another feature of CBMC, if you have a function signature that you have a body for, the prototype, that is also allowed to non-deterministically choose the output of that function. So this is another way of doing that sort of scrambled, uninitialized variable thing. So I get the result in y, and I want to assert y is greater than 0. Okay, great, simple. So if I run it, failure. And if we look at this, what is picked here is this maximum negative integer. And actually, if you think about it, in 2's complement, there's actually one more negative number than there is positive number all the way at the end of the range. So it's not clear really what what I'm intending this to do for a 64-bit integer. It's picked some behavior, I think. And then, okay, so like even still very toy, but a little more realistic. If I have a buffer overflow, I have this buffer, and I'm setting it at 10 equal to 0, and the buffer is of size 10. So 10 is actually the 11th place in the buffer, right? I'm writing off the end of the buffer, and that's a big no-no. That's very bad. And if I run CBMC, verification successful. Oh no. So it turns out that a lot of the checks are off by default. I kind of wish maybe you could. It'd be kind of nice to opt out of them, I think, but this is the way it is right now. So here's a smorgasbord of options that gets you some good stuff. And here it does indeed find in line 3 array buffer, upper bound and buffer 10 failure. That's saying that it's saying it's is writing off the end of the buffer. That's a buffer overflow. And I think that's that's a good start. You start to see what you can do here. You can write basically C programs that check the properties of interest. So your specifications are written in like normal C. That's kind of what I think is so cool about CBMC. One of the things is that you write like normal C. You can sort of arrange these things into unit tests, but unit tests that can cover a very, very, very large range of inputs possibly. And so there's a lot of powerful things you can do when you have this capability. And it's, as I showed, relatively easy to use. You can just download the binary and you just run it on the C file. Now, if you want to be, running it over a big, large project that already has like a bunch of stuff, that's going to be tougher. I kind of have my personal suspicion that it won't scale to like a massive amount of code. It's kind of more at the unit test level, I think, is like the sweet spot for CBMC. You write a unit test, setting up the state in a way that's appropriate to test the thing you're interested in, and then you check the property after you run the thing or during the run of the thing with assert statements. And that's sort of the basic usage that I think it gives you a lot. Okay, so see you next time.